Good afternoon, class. We are looking at the exam 4 review. Chapter 4, Application of Differentiations. Chapter 5, Integral. 6.1, Area between curves. So the first part, 4.7, Optimization Problems. 4.8, Newton's Method. So we're going to cover from 4.7 to 4.9, 5.1 to 5.5, and 6.1. So application of differentiations, integrals, and area between curves. Again, reminding you of this pledge, I want to make sure this is understood that when we take the exam, you should assume we are taking it on campus. Zero assistance. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam. Nothing can be used. In some, you may use a scientific calculator. In some instances, when it's mentioned, you may use a graphing calculator. Differentiation formulas, many differentiation formulas we have seen before, and definition of a E in various formats. Delta Y, rise along the curve. If you have 2 points, you connect them, becomes the secant line, f of x plus delta x minus f of x. And dy is rise along the tangent line, f prime of x dx. Linearization, simply put, means find the equation of a tangent line. Now, 4.7, optimization. And first and foremost, I want to remind you the first or second derivative test for absolute extremum. A local extremum is an absolute one if it's the one and only extremum in an open interval. In other words, I hope you remember the first derivative test, you do the sign graph. If you happen to have an open interval with one critical point, after the sign graph, you figure out it's local, max or mean. But if it's only one, it's absolute. Okay? That's the idea. The same thing for the second derivative test. So these are some examples of optimization problems, and then we look at a couple of them. For example, find two numbers whose sum is 54 and whose product is a minimum. We're not going to do all of them, but I want to make a point, and that is the following. You need to define your variables first. So the two numbers are x and y. So you let the numbers be x and y. You must define your variables. Then the objective is to maximize their product, which is x times y, and it is subject to the constraint that the sum x and y, they must add up to 54. So that's, and you finish the job. I will go over some similar questions as far as different, steps, but that's the idea. If 5,400 pi inch squared of metal is used to construct a cylindrical storage drum, what is the maximum possible volume? So a piece of information from geometry, algebra. Here's the shape of a cylindrical shape. This is the radius, this is the height, and we should know the objective is to maximize the volume, and we should know the formula is pi r squared h. Now, the surface area. So this is the amount that is used to construct. So it's referring to the surface area. The surface area is the area of the base, which is pi r squared times 2, because we have the top and the bottom. And if you cut this open, it becomes a rectangular shape where the base is the circumference 2 pi r, the circumference of the base, times the height and Therefore, the surface area 2 pi r squared plus 2 pi r h must be 5400 pi. So again, understanding a lot of stuff comes from prior knowledge of mathematics, algebra, geometry, you name it. A farmer has 2,400 feet of fencing and wants to fence up a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? So again, you have to draw the setting and define your variables. X represents the width, Y represents the length, A represents the area. You want to maximize the area, which is X times Y. Subject to 2,400 feet of fencing, the perimeter is normally 2x plus 2y, but this side doesn't need it, so 2x plus y must be 2,400. Now, the function that must be optimized, that means you want to maximize or minimize, you're going to work with that. And to work with that, you want to make sure, if possible, to have one variable. In this case, we have two, so you solve for y in this case, and you put it into the objective function. And therefore, it becomes a as a function of x. Now, why is x between 0 and 1200? First and foremost, x represents dimension, must be positive. So x must be positive. Why is it less than 1200? If you set this one equal to 0, x becomes 1200. So if you pick a number larger than 1200, first of all, 1200 makes this 0, can't be. Secondly, larger than 1200 makes this parentheses negative, the area can't be negative. The product of positive and negative becomes negative. So that's the domain. And if you distribute, you get 2400x minus 2x squared. That's the area. And notice from A, we're going to write A of x now because it's a function of one variable. So your domain is an open interval of 0 to 1200. So how do we maximize or minimize? We look for critical points, meaning differentiate. 2400 minus 4x, set it equal to 0, and the critical point becomes 600. Now you do the first or the second derivative test. In the case of an application, second derivative test normally is easier. So what is the second derivative test? A double prime is -4, and all we are interested in is in the sign. You have to plug in 600, but this is independent of x. It's always negative. Negative means concave down, and it means maximum because concave down looks like that. So we proved using the second derivative test, this is a local maximum. However, you have an open interval with one critical point. Therefore, it's an absolute. So absolute maximum occurs when x is 600. You go back to this constraint, replace the x, find the y, becomes 1200. The maximum area is the product of these two, which means 720,000 square feet. This is the way optimization works. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. So what do we need to know? Again, from algebra, geometry, you name it. You should remember this is called a rectangular solid or prism. The volume is the width times the length times the height. The surface area, if you multiply the width times the length to get the base, you need two of them. That's why we have the two. If you multiply the height times the length, we get the face in front, height times the length, which is two of them, the one in front, the one in the back. And the height times the width is the side one. And on the right, you have the same thing on the left. Again, that's why we have the two. If all sides are equal, we call them a cube, and the volume is S cube, surface area SA, surface area, that means gift wrapping in essence, 6S squared. So what happens here? Define your variables. X by H because it's a square base. X by H. The objective is to find dimensions that minimizes the amount of material, so gift wrapping. So if I want to gift wrap, if you look at the walls, it's X times H. All four sides are the same, X times H, because the base is a square. So 4 times X times H. The base is X squared, the area of the base. Normally we have two of them, so plus 2X squared. However, it says open top. We need only one of them. So the objective is to minimize the surface area, which is 4xh, 4 walls, plus x squared. Why x squared? The top is not there. Subject to what constraint? The volume, 32,000. So the volume is x times h. The volume is x squared, h is 32,000. So what is the process? The process is to minimize the function that you see, and it is a function of x and h. You wanted to make a function of one variable, so we are going to use the constraint to solve for h. 32,000 divided by x squared. So s becomes a function of x, 4x times this plus x squared. So 4 times 32,000 is 128,000. X goes away, so does the exponent. We get 128,000 over x plus x squared. To get it ready for the next step, which is differentiation, we are going to bring the x up. We write it 128,000 x to the power of -1 plus x squared. And x represents dimension. There is no other information. X must be positive. In other words, this is our domain, 0 to infinity, an open interval of 0 to infinity. So to find CPs, critical points, we find S prime, and we use this one. S prime of x is -128,000 x to the power -2 plus 2x. This means -128,000 over x squared. And this means x squared is our LCD, the least common denominator. So to make up a fraction here, you have to multiply the 2x by x squared. Becomes -128,000 plus 2x cubed over x squared. Now we are ready to look at critical points. Critical points of a function where f prime, in this case, s prime is 0 or s prime does not exist. First and foremost, s prime does not exist, make the denominator 0, x is 0, is not part of the domain. Now s prime equals 0. A fraction is 0 when the top is 0. So to solve this, you get 2x cubed equals 128,128k. X cubed is 64k. Critical point. Cube root of both sides. 64 gives you 4. 3 zeros go to 1, and x is 40 centimeters. We have an open interval. Let me rewrite this. 0 to infinity. We have one critical point. Whether it's going to maximize or minimize, it will be an absolute. So which one is it? We don't know. What do we do? Second derivative test right here. S double prime. I'm going to use this one, not this one, to do that. The product of these two is positive 256,000 x to the power of negative 3 plus 2. Now the second derivative test says plug in the critical point into S double prime and observe whether it's positive or negative. That's all we are interested in. Now you don't even have to come up with the answer to realize this is positive plus 2 is even more positive. Positive means concave up. Concave up means minimum because it looks like that. So minimum occurs when x is 40. That's the proof using the second derivative test. So if x is 40 and x squared times h is 32,000, then square this 140 squared becomes 1600, divide 32,000 by h becomes 20, which means x is 40, h is 20. So we're going to say this is 40, this is 40, this is 20. And that's all they asked. They asked for the dimensions. However, sometimes they ask, okay, what is the minimum amount of material? You put it in 4 times x, which is 40, times h, which is 20, plus x squared, 4d squared. The minimum amount is 4,800 square centimeters, units of area. What is the minimum distance between the parabolas y equals x squared plus 1, y equals x minus x squared? This opens up, this opens down. I'm assuming everybody can graph them easily. This is just y equals x squared, shifts up by 1. This one you can find the vertex x equals minus b over 2a, and it opens down on a couple of points. So I have no doubts everybody can graph them easily. So what is the minimum distance? Well, couple of points with coordinates. This one would be x, and x squared plus 1. This would be x, and x minus x squared. The distance between the two, the minimum distance, would be a vertical distance, and you write the vertical distance just the y coordinate of this one minus the y coordinate of the bottom one. So this distance, vertical distance, is x squared plus 1, the vertical distance of the top function, the y coordinate of the top minus the y coordinate of the bottom. So we're going to distribute the negative. We get minus x plus x squared, and these two add up. And what is x? There is nothing known about them. X can be anything because the domain is negative to positive infinity for both functions. So this point could be anywhere. We don't know. Maybe it's here. Maybe it's here. Anywhere. So let's go to work. To minimize this, we are going to take the derivative. It becomes v prime is 4x minus 1. V represents the vertical distance, okay? And so to find the critical point, we set this equal to 0, results in x being 1/4. V double prime, we're going to go with the second derivative test, is the easiest one. It's just 4, which means doesn't matter what x is. You really have to evaluate it at this critical point, but it's independent of x. It's always positive. Means v double prime, even if you plug in 1/4, makes no difference. So you don't even have to write this, but I just want to make a point. We are supposed to evaluate it at 1/4. Makes no difference. Concave up, looking like that, gives us the minimum. So the minimum occurs when x equals 1/4. What is the minimum distance? Plug it in, and to plug it in, we're going to use this expression, okay? It's the class, these two are the same. Let me erase my book. This one is the same as this one, remember that. So we are going to plug it in. 2 times 1/4 quantity squared minus 1/4 plus 1. This is 1/16 times 2 is 1/8 minus 1/4 is minus 1/8 plus 1 is 7/8. So the minimum distance takes place at x equals 1/4 and the distance is 7/8. By the way, you can find the coordinates for each one. If they ask you, if you plug in 1/4 into this one, gives you the coordinates for this point and this point, you plug it into this, so you can find the y coordinate for each case. A cylinder is inscribed in a cone with height h and base radius r. Find the largest possible volume of such cylinder. Definitely, we need a drawing, the setting, variables, all of the above. So you have a cylindrical shape inside a cone. So we have the height h and base radius r. That's for the cone. So this is h, the height of the cone. This is r, the radius of the base. Now, this distance and this distance, this would be the height for the cylindrical shape. This would be the radius for the cylindrical shape. So let's call them capital H, capital R. We give them something else. Since they gave us lowercase h and r, we use something else. You can go with x and y, okay? So the volume, as you know, is pi r squared h, the volume for the cylindrical shape. We want to find the largest possible volume. R is missing. We can keep it as R or X. We don't know what R is. The height is missing. But what we know about height, again, you can call it just Y or just say, if this is the H, which is fixed for the cone, and this distance, we call it Y, then capital H, the red one, is H minus Y. So again, R is missing, capital H is missing. However, R is missing, we're going to call it X to work with X. And H from the graph, we see that is the height of the cone minus this distance Y at top of the cylinder. So if that is the case, let's see what happens here. I R squared H, we're going to replace the capital R with X and capital H with lowercase h minus 1. So the volume, remember, we want to find the largest possible volume. This is what we want to maximize. Pi x squared h minus y. And we have no problem with h because h is fixed. Why is it fixed? Because it's the height of the cone. The cone is not changing. It is the cylindrical shape that is changing, okay? So the height is fixed. And because it goes up and down, the y changes too. So we have to find a relationship in such a manner that we get everything as a function of x. So we have to find a relationship between y and x. To do so, if you look at this half as a triangle, look at this one. Maybe this part, another red one. Let's see what color I want to use. Blue one. So this one, oh, okay, it's red one. It's okay. This one and this one. If you look at that one, this one is x. This one we called it y. This distance is h. This one is r. So I hope everybody is clear as to what's happening. This is the triangle. We just make it separated and larger so it becomes clear what we have. And therefore, we are looking at this top one, small triangle, and the entire thing. The two are similar triangles. And everybody remembers two figures are similar if corresponding angles are identical, corresponding sides are in ratio. So I can choose x from the smaller one or from the larger one, x to r. I can pick y from the smaller one, h from the larger one. So this comes from the fact that it's a similar figure. The reason we do that, remember what's happening here. This volume is a function of x and y. H is constant. So we want to get rid of the y. And now this will give us a chance to do that. Y, the cross product, ry and hx are the same. And y is hx over r. And so we can replace the y with it. So v, the volume, is a function of a bunch of variables, x and y. Now it's a function of x because pi x squared remains h minus, and we're going to replace the y with hx over. Now this is a function of one variable. We can work on it. So if I multiply these two, I get pi x squared h. If I multiply these two, I get pi h over r x cubed. The reason I write it in this fashion, and let me erase my word, because I want you to see this is pi h times x squared, and this is something minus pi h over r times x cubed, because x is the only variable. Why is x between 0 and r? And I want everybody to pay attention to this, because if the cylindrical shape is inscribed inside the cone and the cone has a radius r, the radius for the cone, R or X, remember X is must be less than R because it's inscribed in the cone. So in essence, X is between 0 and R, or has some value. All right, so find critical points. How do we do that? V prime. So that to find V prime, we go here and say pi h times 2x, so 2 pi hx, minus pi h over r times 3x squared, or minus 3 pi h over r x squared. I hope everybody's okay with this simple factoring, a simple uh, differentiation. And now I notice that pi and h and x, I can factor it. The reason I'm going to do that, because I need to find my critical points. So if I get pi and h and x out, this gives me 2. Pi and h and x out, this gives me minus 3x over r. So 2 pi hx minus 3 pi h over r. Okay. And we can take the pi hx out. Why did we do that? Because I want to set this equal to 0 for the sake of finding critical points. That's why we did the factoring in this fashion. So if I set this one equal to 0, x becomes 0. If I set this one equal to 0, x becomes 2/3 r. So let me just quickly show you. Either this one is 0 or 2 minus 3x over r is 0. Which means 2 is 3x over r, or x is 2/3 r. So there are two answers. When v prime is 0, there are two answers. You go back to this. Can it be 0? No, because if it's 0, there is no cylindrical shape. Okay, dimensions can't be negative, can't be 0. So this is out. 2/3 r is the only possibility, and therefore local becomes absolute, but we don't know if it's a maximum or minimum. We have to check it. Remember, we want the largest. So we are going to check it with the second derivative test, v double prime. This is v prime. V double prime is just 2 pi h minus 3 pi h over r times 2x. So we get 2 pi h, and from here we get minus 6 pi h over r times x. It's very straightforward, everybody. Now, we have to evaluate this at the CP and observe whether it's positive or negative. This is the second derivative test. So you are going to replace the x with whatever you found here. We are going to replace it with 2/3 r. So multiply this by 2/3 r. So we have 2 pi h minus 6 pi h over r times 2/3 r. Six times 2, 12 divided by 3 is 4. So it's minus 4 pi h. 2 pi h minus 4 pi h is 2 pi h, negative. And by the way, pi is positive, so is h. So minus 2 pi h makes it negative, means concave down. Maximum occurs at x equals 2/3 r. So we prove with the choice of x being 2/3 times the radius, 2/3 of the radius of the cone, we can maximize the volume. What is the largest possible volume? you have to plug it in. So we can use this formula, any of those formulas, any of these formulas. If you pi h x squared minus pi h over rx cubed, we are going to replace the x with 2/3 r. Remember, that was the volume. You can use this one, this one, this one. It doesn't matter which one you use. You get pi h 2/3 r quantity squared 1 minus 2/3. First of all, this one is 1/3. Secondly, this one, you're squaring it. 4 over 9 r squared. So pi h, 4 over 9 r squared times 1/3. You get 4 over 27 pi r squared h. This is the maximum volume. And this is as involved as it gets. So there's a lot of, prior knowledge of mathematics involved here. All right, let's switch gears and let's go to 4.8 Newton's method. So we have a function y equals f of x. Consider a function as it crosses the x-axis. So you have a function, it crosses at some point. So it has some roots, some zeros, crosses the x-axis. So what happens? Newton noticed that tangent line close to the root crosses the x-axis nearby. So take a look. So here's the root, and the tangent line nearby also has a root. The root or the x-intercept for the tangent and the functions are two different points, everybody. However, it's somewhat close. That's the idea. So if that is the case, you can find the location of the x-intercept for the tangent. So tangent line intersection. So you remember the formula? Y minus y1 is m times x minus x of 1. That's how you find the equation of a tangent line. So y minus, so this point is x sub 1. You draw a tangent line at x sub 1, and x sub 1 has a y coordinate f of x sub 1. So y minus y1, that means f of x sub 1 equals f prime of x sub 1, x times x minus x sub 1. So here's the point slope or equation of a tangent line given the point x sub 1. Now this tangent line has an x-intercept. That means you have to set y equal to 0. So if I set y equal to 0, and I divide by this, 0 minus f of x sub 1 divided by f prime of x sub 1 is x minus x sub 1. I can use the negative x sub 1, take it to the other side, becomes x sub 1. So x sub 1 minus f of x sub 1 over f prime of x sub 1 is x. Actually, this is a new point in essence. Use that point as the second and usually better estimate for the root of the function. So This was x sub 1. We draw a tangent line. And this is x sub 2. You draw a tangent line here, and it becomes even closer. That's the idea. So this becomes your new point. X sub 2 is x sub 1 minus f of x sub 1 over f prime of x sub 1. X sub 3 would be x sub 2 minus f of x sub 2 over f prime of x sub 2. And the repeated application of this process is called Newton's method. And we say x sub n plus 1 is x sub n minus f of x sub 1 over f prime of x sub n. Please understand, Newton's method comes from the tangent line. The point slope is the fastest and easiest way to understand this. So to recap, consider a function as it crosses the x-axis, the root. Okay, need to notice the tangent line close to the root, cross the x-axis nearby tangent line intersection is this. So take a look at this one. The graph crosses at some point, and here's the tangent line that crosses nearby. Okay, so you have x sub 1, that's the tangent line. X sub 1, then it gives you this point on the curve. Here's the new tangent line. The new tangent line, the green one, notice, gives you x sub 2, which is even closer to the, you're looking for the red one, which is the actual root. So it gets closer and closer. Again, various graphs so you can see them. You pick a point, you draw a tangent line, and the root, this is the root that you want. This is the actual x-intercept of the function. This is not what we want, but it's some approximation. And then at this point, you draw it. If you draw it at this point, now this one is closer. And then at this point, if you draw it, it's even closer. And that's the idea. Now, only for the Newton's method, you may use a graphing calculator and you use the program here, okay? You set y1 equals f of x, y sub 2 equals f prime of x. You put x sub 1, whatever the number is, as your first choice into x, and then x minus y sub 1 over y sub 2, store it in x, repeated enter, will give you an answer. But you have to show some work. I'm going to explain that to you in a moment with a simple example. All right, first and foremost, this example, calculate 3 iterations of Newton's method to approximate a 0 of f of x equals x squared minus 2. Use x sub 1 equals 1 as the initial guess. Sometimes they don't give us anything, okay? So we have to guesstimate it ourselves. Sometimes they do, okay? So the idea is that if they give us 1, they want 3 more, okay? So what is f of x? X squared minus 2. What do you need? F prime. So you have to write what's f of x, and you have to come up with f prime of x. This is the formula. X sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n. By the way, if f prime, if the tangent line is almost horizontal, makes f prime 0, then this will fail. It makes the next one worse than the previous one, okay? Just so you know. So here's the function. Y equals x squared, and it shifts down by 2 units. That's why this is 0, negative 2. So at x sub 1 equals 1, this is where you have the location, you draw a tangent line. So we get to this point, which is really in essence x sub 2, okay? So what is x sub 2? Following that, x sub 2 is x sub 1 minus f of x sub 1 over f prime of x sub 1. This is general, everybody. This is specific for the second one. Please understand this. I hope everybody's fine with that. So if you want the next one, pick the previous one. I have x of 1, I want x of 2. X of 1 minus f of x of 1 over f prime of x of 1. So what is x of 1? Replace it with 1. Now I'm going to put 1 here. I get 1 squared minus 2 is negative 1. And I put 1 here, I get 2. So evaluate this one at 1 and this one. I hope everybody is clear on that. This makes it plus 1/2, meaning 1.5. So my first number given to me was 1. The one I made up is 1.5. And I'm going to go with that and work with that. In other words, x of 3. Now from here, x of 3 is x of 2 minus f of x of 2. So this is 1.5, this point. And if you graph it, now notice it's almost impossible to distinguish among those. The intercept even better. So x of 2 minus f of x of 2 over f prime of x of 2. So what is x of 2? 1.5. So I'm going to replace this with 1.5. So x of 3 is 1.5 minus f of 1.5 over f prime of 1.5. So now into this, we put 1.5. And that becomes 2.25 minus 2 becomes 0.25. And if I put it in here, 2 times 1.5 is 3. So class, please understand, if I put 1.5, so 1.5 goes into this, gives you 0.25. Goes into this, gives you 3. So you get 1.41666. You use a lot of decimals, okay? Normally they give you how many decimals? We need one more because one was given. We came up with the second one, the third one, and now the fourth one. And this is what I mean. If you show work for 2 of them, that means you know what you're doing. You may use a graphing calculator to calculate because look, here's what you have to calculate. You put this number here, f of this number and f prime. This becomes very tedious. You may use the program that I mentioned, and that's the answer. But to recap, you have to show what's f of x and f prime of x. You have to show this one for x up 2, and at least show work how you arrive at x up 2 and x up 3, and the rest you can use a calculator to make sure we understand that. We're going to look at a couple more examples quickly. We want to use Newton's method to approximate the 8th root of 500 to 8 decimal places. This is what I mean. You really need the program, but you have to show the first few steps. Number 1, you let x represent this one. If you raise this to the power of 8, x to the power of 8 becomes 500. So to solve this, you take the 500 to the left and you call it f of x. So if you find the root or x-intercepts for this function is the same thing, everybody. Root of this function or f prime. So, or x-intercept gives you the same answer. So if you want to go with the Newton's method, you need f prime of x. So you have to write f prime of x is 8x to the power of 7. And now to tell your reader that you really understand, you are going to write this with the information here. So you're going to write x sub n plus 1 for this one. is x sub n minus, instead of f of x sub n, you are going to write x sub n to the power of 8 minus 500. Instead of f prime, you want to put 8 x sub n to the power of 7. This is telling the reader you know exactly what you're doing. So if you want x sub 2, you plug in x sub 1 here. But where do you start? Well, because the 8th root of 256 is 2 and 6,561 is 3, you can start from anywhere. And because ultimately you can use a programming, it doesn't make much of a difference. In many cases, they will give you where to start. So we are assuming the first one is 2. Again, no information is given. So x sub 2 is x sub 1. I hope you can see that. Minus x sub 1 to the power of 8 minus 500, 8x sub 1 to the power of 7. Now, what is x sub 1? Is 2. Why did we choose 2? Because of these two numbers. And 500 is somewhere in between. So replace the x sub 1 with 2. So you get 2 minus 2 to the power of 8 minus 500 over 8 times 2 to the power of 7. See, you show work step by step. You get 2 minus negative 244 over 1024. And you get this number. So when x sub 1 is 2, x sub 2 becomes 2.2328125. Now, you have shown how you go from here to your function, f prime of x sub 1 and x sub 2. You can repeat that, or you can use just a programming calculator. So now, y1 of the calculator, you put x to the power of 8 minus 500 f of x. Y2, you put f prime, which is 8x to the power of 7. You put the 2, you store it in x. And then you say x minus y1 over y2, store it in x, and it gives you this number. This is what we got. All you have to do, enter, enter, enter. So when you enter for a number of times, you get a bunch of numbers. And how do you know when to stop? It says 8 decimals. Notice, if you look at this number 1, 2, 3, 4, 5, 6, 7, 8, the first 8 decimals are identical. That means you can stop. So the 8th root of 500, if you stop here one more time, 1, 2, 3, 4, 5, 6, 7, and you want to stop here, 7 next to 2, okay? And 6 next to 7, 6 next to 7, this 7 goes up to 8. So you write the same thing, 2, 7, 7 changes to 8 because the last number is 6. A quick recap. You want the 8th root of 500, you got to come up with f of x because you say x is that, raise it to the power of 8. This is your function, this is the derivative. You use Newton's method and you put it into that. You have to choose something as your first choice because it's not given. And that is by playing with numbers. X equals 2 works as the first number. You calculate the second number and you show detailed work. That means you know exactly what you're doing. Then you can use it programming that I told you. Y1 is the f of x, y2 is f prime of x. You put the x sub 1, which happened to be 2, in x, and then x minus y1 over y2 over x gives you the first one. In other words, x sub 2, the first one that you calculate. And then enter, enter, enter. Again, I have the programming for you. You can only use it even during the exam for a similar question that requires. You can work on it and see how that works. Use Newton's method to approximate the positive root of 3 sine x equals x to 6 decimals. You Normally they give you some sort of a graph to tell you where to start. So you have y equals x, you have y equals 3 sine x, and they want you to find the positive root. They are looking for this one, everybody. So how do we find that? First, you have to come up with the function 3 sine x equals x. You have to bring everything to the same side and call it f of x. For example, you can move the x to the left side. So this is the function that you have. So if that's your f of x, you need f prime of x. What is the derivative? 3 cosine x minus 1. So again, this has got nothing to do with the Newton's method. It has got to do with understanding the function and how to differentiate it, f prime of x. So if I want to write this for the function f of x and f prime of x, I plug in and I write x sub n plus 1 is x sub n minus, the numerator is the function 3 sine of x sub n minus x sub n over 3 cosine of x sub n minus. So I'm telling my reader I know exactly what to do step by step. So if I want x sub 2, then this would be x sub 1. So replace everything here with x sub 1, over here x sub 2. But why x sub 1 is 2? Because you have to choose something. You can see that this one, we may not know the x coordinate, but it's close to 2. So it's clear that the best course of action is to choose number 2. So plug in. So we are going to plug in 2 wherever we see x sub 1. Now 3 sine 2, it's not a common arc. You have to put it into a calculator. Minus 2, 3 cosine 2, the same thing. So you put this into a calculator and you find x sub 2. So if x sub 1 is 2, x sub 2 is 2.323732, because we are looking at 6 decimals. Now, I have shown my work with details here. Now I can use a calculator to finish the job. And that's what I'm going to do. Y1 is f of x, 3 sine x minus x. F prime is y2, 3 cosine x minus 1. The first choice was 2. So store the 2 in x, and then x minus y1 over y2. Okay. And enter, and enter, and enter. So x sub 3 is this number. We want with 6 decimals. Okay. Remember, this was the second one. This is the third one. 2.2795994. Next to it is 8. We take it up to 5. The next one, again, 6 decimals, 2.27886. And we want 2 next to it is 6. It goes up, becomes 3. And it happened to be the same as the next one. Notice the next one is the same. Since x sub 4 and x sub 5 are the same within 1, 2, 3, 4, 5, 6 decimals, we stop and we say the answer is 2.27886.